Okay, hello everyone. So today we're going to talk about rational exponent. So rational exponent. So in this class has two parts. The first part is the radicals. So here is radicals. Radicals. So what is the radicals? Any idea about radicals? What is the meaning of radicals? Maybe you heard it in high school, or do you know what is the meaning of radicals? Okay, let me remind you what does that mean. Yeah, square root, exactly, Matthew. This is correct. Cube root, exactly. etc. Yes, this is correct. So radicals, for example, I'm going to start from like the simplest radicals is the square root of a. Suppose this square root of a equal b. This is mean here, actually we have two, small two, but it's hidden, okay? So square root of a, this is mean like here 2 equal b means, this is means if we multiply this again by itself, like I mean b square, they will give me a. So b square equal a. This is mean the square root of a equal b. This means if I multiply b by itself, they will give me a. And you have to know b is greater than or equal 0. This is mean b is positive number and or 0, and in the same time, because we have square, a must be greater than 0 or equal 0. For example, for that, suppose I have, for example, so square root of a, square root of 9, what is that equal? What is the square root of 9?
3.
3, exactly. So this is mean the same things. If I multiply the 3 again by itself, they give me the 9. This mean the answer is correct. So 3 square, they give me 9. And the 9 is inside. So, and you have to know the 3 is positive, the answer is positive, and the 9 is positive also. So if I want to make it in general, definition in general, this is like for square root, the simplest one. So suppose that in general, n is positive integer. Suppose I have n is positive integer, okay? And so I can define the nth root. Here is called out the ups here. This one is the square root, but I'm going to define it as for the nth root. The nth root of a is given like this. So it's given like square root, the nth root of a, this is equal b. So again, if I want to use it, the same idea in the above here, this is mean if I raise the b to the power n, they will give me a. And you have to know if n here, if this n is even number, this n like even is even number. What is the even number? What is the even number? What is the mean of even number? Any idea what is the mean of even number? Multiple of 2. Yeah, this is correct. Like 2, 4, 6, 8, 10. All these numbers is even. Yes. If n here is even, like 2, 4, 6, 8, 10, 12, whatever, so both of a and b must be positive or 0. So both of a and b must be positive. So then I can say both of a and b are positive or 0. So this 0. I mean, this condition is very important. You have to know if n is even, so both of a and b must be positive or 0. But if it's odd, whatever, sometimes be positive or maybe will be like negative. It's fine. I give you some examples. Can I get the attendance? Yeah, you can get the attendance. So any student can give him the attendance, please? Yes, thank you. Anta, thank you, Anta. Okay. So for example, if what is like here example, the question is, what is the square root of 81? What is this answer?
9.
9. Why? Because 9 times 9, they give me 81. And you have to know here, the square root is even number. So must of 81 and 9 be positive because 9 times 9 square equal 81. And both of 81 and 9 are, are positive. Another example is the third root of, or the cube root of minus 8. What is the answer? Minus 2. Yeah, this is correct. Why? Because minus 2 to the power 3, this one, this 3, they give me minus 2 times minus 2 times minus 2. They give me what? Minus 8 inside 1. So this is correct. And also look, it's odd number, 3. Odd number, this is mean if it's odd, the answer is odd. And I can plug odd, I mean, like I can plug a negative number. Look here, the minus 8 is negative numbers. So I can plug here negative because odd, I mean odd root, 3. The 3 is odd, so I can plug negative here. It's fine, will not be give any issues. But because here is even 2, here must be positive, must be positive. Another example, the fourth root of minus 8. What is the answer? What's the answer for the third one? Yes, what's Matthew? Because it's negative, so what does that mean? What is the answer? It has answer here? Okay. So Matthew said because here the 4 is even and here we have negative. Michelle, they said undefined. This is correct, undefined. The answer is undefined. Why? Because we have here even number, the 4, and plug it inside negative. So undefined. So this is correct. Why? Because the minus 8 is negative. Because negative 8 is less than 0. This is mean is negative. It must be positive here. Okay, any question?
Yeah, I have a question.
Yeah, what's your question?
So I still don't know exactly why if it's undefined for 3, why is it not undefined for 2?
Because for the 2 is has odd root. 3 is odd. I mean, for odd, it is a 3, 5, 7, 9. All of them are odd numbers. But for the even numbers is must we have to plug in under the root positive number. So because we have even here 4, the 4 is even, here must be positive. But here we have odd. Odd, I can plug anything, positive or negative. Doesn't matter. Make sense?
Okay, thank you.
Okay. Okay, I'm going to give some properties. Here are some properties for radical. Uh, so first one said the nth root of a times b here, and we can separate the root as the nth root of a times the nth root of b. Example for this, easy example. The third root of minus 27 times 64. So this will give me the third root. I can separate the minus 27 times the third root of 64. What is the third root of 27? Cubic root of minus 27?
-3.
Negative 3. That's correct. And what is the cube root of 464?
4.
4. So the answer is minus 3 times 4 is minus 12. Okay, second properties. The second property said the nth root of a over b is equal the nth root of a over the nth root of b. Same idea like before. Example here. The third root of 27 over 64. So the same idea, I can make two root, the third root of 27 over the third root of 64. And this equal, the same idea here is 3 over 4. 3 over 2. Yeah, this is correct, Zainab. Thanks. Okay, the third property. Any question for this two property?
No.
Okay. What about the other student? Okay, let's go to the next slide.
Wait, can you go back for like a few seconds?
Yeah,
please?
sure, no problem.
You can go back now. Thank you.
Okay. So now the third property, 3, said if I have the mth root of nth root of a, this is equal, I can get one root only, and here I can do multiply of m times n, m times n of a. Example, the third root of the second root or square root of 9, and this is equal 3 times 2
That's 6.
6. 3 times 2 over 9 for the root 9, and this is equal the sixth root of 9. The fourth property, the last property for radical, said if I have the nth root of 8 to the power n, this is equal two things. The first one is a if this an is odd, if n is odd number, and also is equal the absolute value for a if n is even. Do you know what is the mean of absolute value for a? Any idea for this? What is the mean of absolute value? Distance from 0, this is correct. Distance from 0, this is correct too. Or I can say the absolute value for a is always make the number inside positive. For example, square the absolute value for -3, they change it to the positive equal 3. And we keep the positive the same as positive. For example, square root the absolute value for 2, give me 2. So they're changing the minus to the positive. Again, the absolute value for -5, give me 5. So here, if n,
I
this
have a
n is,
question.
yes,
What if the negative sign is outside of the absolute value, like brackets?
they will not affect the absolute value. They will keep it minus. For example, if I have something like that, the negative of absolute value for 5, this is equal the -5.
-5.
Yeah. If I have another one, like the negative outside and inside 5, this is equal the negative here, give it outside, and we change the -5 to 5, so they give me -5. Make sense? So
I
here,
have another question.
yeah, what's your question?
If you have an equation with parentheses and you put absolute values around that, do you do the parentheses first or the absolute value first?
If I have, what's your question again? If I have absolute value like
If you
this,
have, if you have an equation in between your absolute values with parentheses around it, would you solve the parentheses first and then do absolute value? Or
yes, exactly.
okay.
Yes, yes. We do the parentheses, then we will take the absolute value. So here, if I have n is odd number, doesn't matter inside. If it's negative, we keep it negative. If it's positive, we keep it positive. But the problem here, if n is even, this n is even, so here must be positive. How can I make it positive? I take the absolute value. Make sense? So if n here is positive, even, because if it's even number, inside must be positive. So to take the positive, I have to take the absolute value. But if n is odd, doesn't matter inside, negative or positive, they will not affect the nth root. So I'm going to give you example for this. For the last one, the properties. Here example. So find the third root of x to the power 4. So to do something like this, first things, x to the power 4, I can make it like x to the power 3, I keep it the same root, the third root or the cube root. X to the power 4 is equal x to the power 3 times x. Why? So I have the same base and the exponent are different. I have here 3, here I have 1. So 3 plus 1, they give me 4. So this expression is the same as this expression. So I keep the same root, the third root or the cube root of x to the power 3 times x to the power 1. Now, by using the first property, up to the first property, I can make the third root as, like I can separate the root, 2 pieces. First piece, second piece. So I'm going to do these things here. So this is equal the third root of x to the power 3 times the third root the x to the power 1. Now, this one is the same as property number 4. Look to the number 4. I have n and n. Here the n is 3 and the 3 is odd number. So the answer will be A, wherever A is it. So A here is x. If we look at here, the A is x. So the answer is x times, here we keep it the same things, times x, third root to the power x. Any question for this one? Makes sense? Is it clear?
I just
Yes.
don't understand how, like, you see how you split it like x to the power of 3 times x to the power of 1, and on top of it, yeah, right there.
This one?
Yeah, that one. Did
Okay.
you like split it? Like, did you like, because it's like 3 plus 1 equals 4, or what? I'm
Yeah.
confused.
So x to the power 4, this is like we learned last time. If I have the same base, yes, I split it to the 2 pieces. X to the power 4 is x to the power 3 times x to the power 1. If I have the same base, the base here is x, and the exponent are different, 3 and 1. So we can do sum to the power. So 3 plus 1, they give me 4. So actually, x to the power 3 times x to the power 1 is the same as x to the power 4.
Okay, why couldn't you do x squared times x squared? 2
A
plus
nice
2.
question. Nice question. Because I need some of this have the same, the exponent have the same number, the same n
odd?
here, the same root, the same number
Oh,
of the root. So I have 3, so I keep 3. Why? Because I need to cancel the
canceled
root.
it. Yeah.
Exactly. I need to cancel to applying the property number 4 to cancel the root with the power.
All right, I got
Actually, I need to cancel the root with the power. Here we cancel the root with the power. So if n is odd, but if n is even, I just put the absolute value to make it positive. So if here I have 2, here I have 2, I mean the square root. So I have to put here the absolute value.
Can you wait,
Yes.
can you give us an example, like if n is even?
Even? Okay. This is clear here for the other student? Yes, here I get Layla. Yeah, this is correct. Okay, for even one. So if I have, for example, the fourth root, here example, the fourth root for x to the power 5. So this is actually equal the fourth root for x to the power 4 times x to the power 1. Why? Because 1 plus 4, they give me 5. Same base, x and x. And we have multiplication between these two variables. So this expression equal to this one. Now I can split it 2 pieces. First one is the fourth root of x to the power 4 times the fourth root to the x of x. Now we have here even by using the probability number 4. If n is even, I take the absolute value for a. So the absolute value for a here is the absolute value for x. The absolute value for x. This is my a. Times the 4th root of x. Done. Make sense?
So in your final answer, would you just leave it as that, or would you have to get rid of
Yeah,
the absolute value?
just leave it like this.
Okay.
Any other questions for the example?
So only if n is an even number, you put the absolute value. If it's odd,
Yes.
you don't put it.
Yes.
Okay, thank you.
No problem.
Can you go to the previous slide? I just want to get a
Yes.
picture.
I post the link for all lectures and the notes in Google Drive. Okay, so the rational exponent now. The second part of this section is the rational exponent. So we talk about radicals in the beginning. Now the rational exponent. So this section talk about this part in this section talk about something like this: a to the power m over n. M over n. So this is actually, I have to make it in radical as the nth root. So this is the nth root here of a. This is a to the power m. This m from here, m. So here m over n, more clear, m over n. So the n, it's in the denominator of the fraction. So will be like the root. And the m is the exponent or the power of a. Or we can define it as, a to the power m over n, m over n. This is equal the nth root of a, the mth root of a, everything. I mean here n, here n, here is n, everything to the power m. So I can put the m inside or outside, both of them correct. Example for this, 4 to the power 1/2. Was that equal? 4 to the power 1/2.
Square root of 4.
Square root of 4. This is correct. So square root of 4 to the power 1. So to the power 1 is same number as 4. So the square root of 4 is, what's the answer?
2.
2. Okay, another example is 125 to the power minus 1 over 3. What is the answer? Same idea like before here. Is the, which root is this? Here I have minus. What is the meaning of minus? Like I said before. Yes, this is correct. The minus mean, I have to put this one in the denominator. So this is equal 1 over 125 to the power 1 over 3. Now, what is this mean here? 125 to the power 1 over 3. Yes, Matthew. This is the cube root of 100. This is the cube root of this one, right? Second one. So this is equal 1 over
5.
the cube root of 125. And the cube root of 125 is 5. So the answer is 1 over 5. No, we cannot use the calculator. So the answer is 1 over 5. Okay. Second part of this question, second part, like for rational exponent, we have to know how to simplifying also. So this is clear here. Any question for these two examples? So here, example 1, here, example 2.
I have a question. What if you cube the entire fraction 1 over 125?
No, this is not. Yeah, we can do this because the cube root of anyone for the one always true. But here, if the exponent is not minus 1 over 3, for example, minus, yeah, this is correct for everything. If I put all of them the cube root or the third root, that's correct because the one always they give me 1 for any root. This is correct.
Okay.
Yeah, because the one here in the numerator for any exponent they will give me 1. So you can put the cube root for everything or for only the part of in the denominator. Okay, so now simplifying the same like before, but we have to use the simplify for rational exponent and radicals. So example, simplifying. So the question is 2a to the power 3 over 4 everything to the power 2 times 7a to the power 1/2. So like I said before in the previous lecture, I have to distribute the 2 inside the parentheses. Then I have to combine the numbers together and the variable with they have the same letter together. So first of all, we have to distribute the 2 inside the parentheses here. Can you go back so I can get, yeah, I will go back. Here is the previous slide. Natasha. Okay.
I got it.
Done, Tasha? Okay, for this one, I have to distribute the 2 inside the parentheses like we learned before. So I get 2 to the power 2 times a to the power 3 over 4, everything to the power 2 times, here we have 7 a to the power 1 half, 7 times a to the power 1 half. Now the 2, and we have another, like here, the a has first exponent is 3 over 4, and everything to the power 2. So here I get, first of all, 2 to the power 2, they give me what? 4 times a to the power 3 over 4. We have to multiply the 3 over 4 times the 2. What they give me? What is 3 over 4 times 2? What is the answer?
Would it be 6 over 4?
Yes, this is correct, because we don't have addition, we have to multiplication. So you just multiply the 3 times 2 over 4 times 1, because the 2 is actually over 1. So I get 3 times 2, they give me 6 over 4 times 7 times a to the power 1 half. Now, like I said before in the previous class, we combine the numbers together. So I have here 7, the 4 with this 7, and we combine the letter, they have the same, the variable have the same letter together. So I have this one and I have this one. So again, 4 times 7, 4 times 7 times a to the power 6 over 4 times a to the power 1 half. So 4 times 7 is 28. 28.
And you have to
And
add
a,
exponents, right?
yes, exactly. We have to add the exponent 6 over 4 plus 1 over 2, because we have the same base, a and a. So we just have to add the exponent 6 over 4 plus the other exponent 1 over 2. What is 6 over 4
8,
plus 1 half?
8 over 4.
8 over 4. 8. How you do it?
You have to multiply
Multiply by
2
2,
by
right?
2 and then 1 by 2. So it's going to be 2 over 4, and then you have to add the numerator.
Okay, correct. So the answer is 6 plus 2. So they give me 8 over 4, because the denominator are right now is the same. So 8 over 2, 8 over 4, they give me what? After we canceling and we simplify, they give me 2. Exactly. So actually this give me 28 times a to the power 2, or a square. Any question?
So we shouldn't combine the 28 and the a squared.
A 28 and where?
Can, right?
And the a
20,
squared.
Like the
28.
answer would be 28.
No, yeah, this is, they will equal like 28, sorry, 28 a square. This is the final answer.
Okay.
Yes, this is the final answer, 28 a square. Any other questions? Okay, another simplifying is more harder than this one. Okay, I'm moving to the next slide. So the question is, again, simplifying expression. Example number 2 is is 2x to the power 3 over 4, everything for this one, over y to the power 1 over 3, everything to the power 3 times y to the power minus 1 over x to the power minus 1/2, everything to the power without power. Like this. So when you see something like this, first things we have to distribute the 3, this one, inside the parentheses, like I said before. Then we combine the numbers together and the same variables together. So here the 3 we have to combine it inside, we have to multiply everything inside. I mean, we have to raise everything inside to the power 3. So I get 2 to the power 3 times x times x for 3 over 4 times 3 over y for 1 over 3 to the power 3. Then this multiplied by the second fraction is y to the power minus 1. So y to the power minus 1, I can put it down. And here we have x to the power minus half. So this goes up, like I said before. So the minus exponent will go down to the from the numerator to the denominator. And the second one here, x to the minus half, 1/2, they will go up to the numerator. So I get here x to the power half, 1/2 over y to the power 1. Now we can simplify this fraction here. So I can get equal 2 to the power 3, they give me 8. And here I can make one fraction for everything, just one fraction. So the first one here I get 8 because 2 to the power 3, they give me 8. X to the power 3 over 4 times everything to the power 3. So I just multiply the two exponent. So I get here times x to the power 3 times 3 is 9 over 4 times. Now this one I bring it here. So x to the half, 1/2. Down in the denominator, I get y to the power 1 over 3, everything to the 3. So I just multiply the 3 with 1 over 3. They give me y to the power 3 over 3 is 1, right?
Yeah.
1. And here I just move it to the other side. So multiplying by y. Now I combine the variable together. So I get here 8 times x to the power 9 over 4. And here we have 1 over 2. So we have to sum the exponent together. So this will equal x to the power 9 over 4 plus 1/2. Down, I get here 1 and 1, so it will give me y because I have the same base, different exponents. So they give me y to the power 1 plus 1. They give me 2. Now 9 over 4 plus 1/2, I will do it here. 9 over 4
11 over 4
plus 1/2. So I just multiply the 2 with what, Naila? With 2, right? So now I get 9 plus 2 over 4, and this is equal 11 over 4. Now here I can get equal 8 times x to the power 11 over 4, everything to the y to the power 2, y to the power 2. If the question told you don't write the answer in the negative exponent, I mean don't write the answer with the fraction, just you have to write it like this, equal 8 times x to the power 11 over 4 times, now if I want to raise this one up, what I have to do? If I want to raise this one or move this one,
Is it y to the power of half or negative half?
is not half, is 2. What's the exponent?
Negative.
Negative 2. Yes, this is correct. So to moving this one from the denominator to the numerator, I have to change the sign for the exponent from positive 2 to negative 2. And this is final answer. So I can remove the multiplication. They give me 8 x to the power 11 over 4 and times y to the power 2. Any question?
Shouldn't that be -2 in the answer?
Negative 2 here. Sorry. So 11 over 4 times y to the power minus 2. Yes, and 8.
So for the final, do you prefer us to write the y with the negative, or like put it under the, you don't care if we put it under the?
Yes, you have to write it like this. If I told you don't write the answer as a fraction, without a fraction, you have to write it like this. 8 times x to the power 11 over 4 times y to the power minus 2. But if I did not specify what's the answer, you can write it like this as a fraction. Okay, so the last example in this section is a Weber-Stein question. The answer is, the question is example here. So this is Weber-Stein question. The question is, if I have 14 to the power 4 over 5. Yeah, I will go back just 1 second. I want to write the question. If I have 14 to the power 4 over 5 plus square, this is equal it's not the question exactly, not the plus square, is multiplying by multiplying times 14 to the power square. This is equal 14. So what I have to write inside the square? I back Jonathan.
Wait, the answer was 14 to the power of what?
14. Okay, so if okay, 14 to the power 1.
Oh,
Or
just 14?
yeah,
Okay.
to the power 1 or without 1. The answer is 14. So what I have to write inside, what exponent I should to write inside this box to give me 14? Matthew said -4 over 5. if I put here minus 4 over 5, they give me 14 over 4 over 5 times 14 times minus 4 over 5, and they give me 14 to the power 0, and 14 to the power 0, they give me 1, not 14. 14 to the power 0, they give me 1, not 14. So this is not correct.
Is it 1 over 5?
1 over 5. Let me try, because 4 over 5, and here I have the same base. So this is actually equal 14 to the power 4 over 5 plus 1 over 5. And this is equal 14 to the power 4 over 5 plus 1 over 5. They give me 5 over 5. And 5 over 5, they give me 1. So the answer is 14 over 1, and this is equal 14. And this is correct. So here inside the box, I have to write 1 over 5. Yes, this is correct. So if I want to think for this question mathematically, so I have to set, I have the same base, 14 and 14. So I have to write it like this. And I have to set 4 plus 5, 4 over 5, plus this box. This is equal 14 to the power 1. So this is mean 4 over 5. So I have to set here 4 over 5 plus this box equal 1. So to know what's the value inside the box, I have to subtract both sides by 4 over 5. I get 1 minus 4 over 5. And the 1 here is actually over 1. So this is actually here 1 over 1. So I have to multiply both sides by 5 to make the denominator are equal. Multiplying by 5, multiplying by 5. Now I will get this equal 5 over 5 minus 4 over 5. So 5 minus 4 over 5, and this is equal 1 over 5. So the box here should be 1 over 5. So the answer here, this is 1 over 5. Any question? Anyone has a question for this section? Okay, so this is the last example in this section. Now we go to the next section is algebraic expression, P5. Algebraic expression here, P.5. Can you go back? Yes, I will go back. Okay, so algebraic expression. So this section, so in the beginning of this section, talk about the expression in math. So we have to know so we have to know what is the meaning of algebraic expression. So variables like this. If I have variables like x, y, z, these variables and real numbers all these variables with the real numbers combined together, to each others by like addition, or by like subtraction, or like multiplication, or like power, for example, power, or roots. So all of them make the algebraic expression. I'm going to give you an example. What is that? To explain more for algebraic expression. So it's a variable like x, y, z, and real numbers combined to each other by, if I have addition, subtraction, multiplication, or division, or power, roots. All of them make the algebraic expression. Example for algebraic expression, like something like this. I have 2 to the power x squared minus 3x plus 4. So look, I have real numbers 4, 3, 2. And also I have variables x squared. And also I have operation is minus and plus. All of this are combined to each other and they give me algebraic expression. So this is an example of algebraic expression. Another example is the square root of x plus 10. So this is algebraic expression because I have the square root of x plus 10. Another one is, for example, the y minus 2z over, for example, y squared plus 4. And also this is an algebraic expression. So all of these three examples are algebraic expression because I have here, for the third one is algebraic expression because I have variable is y and z, and also I have numbers is 2, and I have here 4. Also I have the operation is the minus and addition, and also I have the division between the numerator and the denominator. So all these three are example for algebraic expression. So we get just only an idea for what's the meaning of algebraic expression. Now let's talk about polynomial. But before we start to talk about polynomial, let's starting by talking about the simplest one of the polynomial is called monomial. So monomial, this is an like some question and we will sign about monomial and binomial. So if I have, for example, so the definition of monomial is like this. The monomial is an expression of the form like a times x, a times x, such that a is the real number and x is a variable. But here we have only one term like a and x. Okay, like the x to the power k, the x here to the power k, and the a here is real number. So here the a is a real number, and the k here is non-negative number. Non-negative. What's the meaning of non-negative number? The non-negative number is the 0, 1, 2, 3, 4, 5, 6, 7. All these numbers are non-negative. I mean, doesn't have fraction, like doesn't have like 1 over 2 or 3 over 4, because 1 over 2, they will not give a monomial. The second, here Laila said one number Yeah, I mean like is not number. I mean like one term is correct. You have to say one term. I mean for one term is they have only term of this form. A number real numbers times variable to the power k. K is any non-negative number. Now the second definition is called binomial. Binomial. So the binomial is similar to monomial, but the difference here we have two terms. We have is a sum of, I can say is have two terms of the form this like this, or I can say is an expression is the sum of two monomial is the sum is an expression of, I can say here is a sum of two monomial is a sum of two monomial. Like if the sum of two term, I mean like two term of like this, and between these two terms are sum. So here is the monomial. The third one is called a trinomial. So let me give you an example before we moving to the third one. So the first example here for the monomial example, like 4 to the power times x to the power 2. This is monomial. Another example, who will give me like example for a monomial? Any idea or example for monomial? I gave one example. Who will give me the second one?
5x to the third
5x what?
to the third power.
To the third power, yes. What about number 5 only? Or number 6? Like something like this. Or 7. This is monomial.
No, because only consists of real number. You also need an exponent.
But the 7, who said 7 is monomial? And who said 7? Who in the beginning? Who said 7 is not monomial? Who said 7 is not monomial?
I did.
Okay, who else said the 7 is not monomial? Two. I have only two. They said 7 is not monomial. Who said the 7 is monomial?
I think it's monomial.
Why is monomial?
I mean, I just
Can I write it as a form of this? This is monomial. This is correct, but how you think is monomial?
I mean, I learned this probably in 9th grade. I just remember monomial being either a product of a real number and something else with a real number exponent.
Okay.
And it can be by itself too.
Yes, this is
That's
correct.
what I remember.
Okay, this is correct, but I can also using this here, the form here, because I said is expression of the form a times x to the power k. So a times x to the power k, I mean the k is non-negative. I mean like could be 0 and any positive integer number. So the 7, I can write it as 7 times x, the variable, to the power 0. So the k here is 0. And anything to the power 0 is 1, like we said before. So 7 times what? 1. And this is equal 7. So the 7 is a monomial. Yes, Zainab, this is correct. So the 7 is also a monomial because I can write it as 7 times x to the power 0. And anything to the power 0, they give me 1. So it's actually equal 7 times 1, and this is equal 7. And the 7 is also monomial. Binomial is a sum of two monomial. any sum of two monomial is called binomial. Example for this, 4x squared plus, for example, 5x. This is binomial, because I have two terms, sum of two terms. Another example is, for example, 4x to the power 2 plus 7. This is also binomial. Okay. Now, the last one is, after the monomial and binomial, we're going to talk about trinomial. So here, third one is trinomial. Trinomial is a sum of three here. Instead of two is three. I have sum of three monomial. The sum of three monomial is called a trinomial. The same idea like before, just we're adding three monomial. For example, 4x. Here we have example 4x squared plus 7 plus, for example, 2x plus 7. This is called trinomial. Another example is 4x to the power 16 plus x to the power 2 plus x. This is also called trinomial. Okay. Now, the last one, after we talk about monomial, binomial, trinomial, we're going to talk about polynomial. So polynomial is the sum of monomial. So the greatest one is called polynomial. So the polynomial is the sum of a number of monomial. So I can say the trinomial is polynomial, and I can say also the binomial is a polynomial. So here the polynomial can define. So I can move to the next slide. Everything's fine here. So the last one is the polynomial. So here the polynomial. Polynomial is a sum of monomial. So this is the greatest one. So the greatest one is this one. Now, I give you example for this one. For example, 7. The number 7 is polynomial. 2x plus 1. This is a polynomial. 7x squared plus x plus 1. This is a polynomial. 5 times x to the power 17 plus 2. This is a polynomial. Okay, so it's a sum of monomial. One monomial, two monomial, three monomial, whatever. Sum of monomial called polynomial. So I'm going to give you the formal definition for polynomial. So the polynomial, I can set here, polynomial is an expression of the form, like is expression of the form like this. Anything of this form is an x to the power n plus an minus 1 x to the power n minus 1. You don't have to memorize these things, just you have to know what's the meaning of polynomial, like general formula for the polynomial. So I mean here, if the number a0 is a number, all of this a are real numbers. So if I have number, for example, only without the variables, it's called polynomial. If I have 2 term, it's called polynomial. If I have 3 term, they call polynomial. So I can say here the numbers are real numbers. All the a's are real numbers here. Real numbers. And the x here, x and x are variables. So okay, so now after we know what's the meaning of polynomial, I'm going to give you example. This example is similar to the web assigned question. The question is like this: if I have table like that, term and the degree. By the way, the degree is the highest power of the polynomial. The highest power. For example, the degree here is the highest power of the variable x, so it's 1. Here, the degree here, the highest power here is, what's the degree for the number 7? What is the highest power here for 7? Before we go to the 7, what is the highest power here? And the third one, we have 2 and 1, and we don't have here anything. So the highest power is 2. What is the highest power here? We have 17. So the power here is 17. Now we go back here. What is the power here for the 7? Any idea? What is the power for the 7? For this one? Yes, x to the power 0, exactly. This is correct, thank you. The 7 has, it's like the same, like I said before, 7 times x to the power 0. So the power here is, what's the power here, Pamela?
For that, 7 would be x to the power of 0, right?
So what's the degree?
The degree would be 0.
Yes, this is correct. So the degree for the 7 is 0 here. Thank you. For the second one here, the question is type of the polynomial. The third one is the third one is a term, and here the degree. So if I have something like this here, like 2x to the power 2 minus 3x plus 4, and if I have here ax square, and if I have 6. So the first one, what is the type of the polynomial for the first one? What's the type for the polynomial? Is it monomial or trinomial? Yes, this is trinomial. This is correct because I have 3 terms. The first, second, third. So this is called trinomial. Trinomial. What is the term? Is 2x squared, comma, 3 minus 3x, comma, and 4. What's the degree? What's the highest power? Is 2. Exactly. So the degree here is the highest power. We're looking for the highest power. Now for the second one, what is the type? Ax square. Monomial. Yes, exactly, monomial. What is the term? Is the same as ax square. What is the degree? It's 2. Now for the third one, what is the 6?
Monomial.
Monomial again, yes. So here I have monomial. What is the term? Is only 6. What is the degree again? What is the degree for this monomial?
It would be 0.
0, yes. The degree will be 0. So this is a web assigned question similar to this question.
I have a question.
Yeah, what's your question?
Why isn't it 1 instead of 0?
Why is 0? Because the 6 here is look like as 6 times x to the power 0. So here the highest, because x to the power 0 they give me 1, and 6 times 1 they give me 6. So the highest power here in this expression is 0. So I have to put 0. But if I have something like that, 6 times x to the power like this, 6x. So the type here is monomial. The term is 6x, and the degree here is 1. Why 1? Because the highest power it shows in the variable is 1. Make sense?
मैं नाले त्री चालियां तक क्लास खत्म हो
Okay.
20 मिनट बाद
Now, now let's go to the something connect to the polynomial is called adding and subtracting polynomial. So we're going to learn how to add and subtract polynomial. So here adding and subtract. Yes. I will go back. Hold on 1 second. So adding and subtracting polynomial. Okay, you're welcome. So for adding, I'm going to give example for this one to explain how we can add and subtract polynomial. So the example is, if I have two polynomials of the form x to the power 3 minus 6x squared plus 2x plus 4, and this is plus another polynomial is x to the power 3 plus 5x squared minus 7x. So I have two polynomial. Between of these two polynomial are the sum sign. So the question is add these two polynomials. So to add these polynomials, I have to do something is called a grouping the same term. So first of all, I have to make the term has the same power together, and so here, first of all, I have to remove the parentheses. So the first step, I have to remove the parentheses. So I get here equal x to the power 3 minus 6x squared plus 2x plus 4. And because we have adding here, so we can remove the parentheses. So plus x to the power 3 plus 5x squared minus 7x. Now the second step, I have to combine the variable have the same power. So this one and this one have the same power. And also this one and this have the same power. The power here is 2, the power here is 2. The power here is 3, the power here is 3. For the third one, this one here, the power is 1. Here we have one that has the same power, 1. So here this one will combine to this one, and the 4 we left it. We don't have another numbers. So the answer now equal x to the power 3 plus x to the power 3 minus x to the power 2 plus 5x to the power 2. Now, the last one is plus 2 to the power x minus 7x. And the number left by itself plus 4. Now, when we adding two variables have the same powers, just we adding the numbers in front. So here we have 1 actually, and here we have 1. So the answer is 2x to the power 3 minus 6 plus 5 minus 6 plus 5 is minus 1 x to the power 2 plus 2 minus 7, they give me minus 5 times x to the power 1. And we're lifting here plus 1. And this is the final answer. Any question any question for these things? Is it clear how we add two polynomial?
Yes, it's clear.
Anyone has a question? It's clear. Okay. What about the other student? So now we learn how to add polynomials. So first step again, we have to remove the parentheses, combine the variable have the same power together. Then we have to add the numbers, the coefficients for each term. Now we have to learn also how we can do subtraction of between two numbers. So the second example is like that here. So the example number 2 is subtraction example. So I'm going to use the same numbers, the same example, the same polynomial, but instead of plus here, I'm going to use minus. So x to the power 3 minus 6x to the power 2 plus 2x plus 4 minus x to the power 3 plus 5x squared minus 7x. Now, like I said before, we have to remove the parentheses. But before we remove the parentheses, here we see minus. So the minus sum must be distributed inside the parentheses to remove the parentheses. I mean, the minus should be goes down here inside the parentheses. We have to distribute the minus inside the parentheses. So now I get, so this is equal now x to the power 3 minus 6x squared plus 2x plus 4. Now the minus we distribute inside the parentheses, I get minus x to the power 3 minus 5x squared plus 7x. equals 0. Now we have, I mean, not equal 0. Now we have to combine the variable have the same exponent together. So here I have x to the power 3. Here I have x to the power 3 with x to the power 3. I have 6x squared again. I have this one with this. And we have also the 2x with the 7x and the number left alone. So this is equal x to the power 3 minus x to the power 3. So they cancel each other. Plus here we have minus 6x squared minus 5x squared. And this one is plus 2x plus 7x. And the last number here, number 4, plus 4. Thank you, Bamil. She's the student here, Bamil, solve it. So x to the power 3 minus x to the power 3, they cancel each other, 0. Minus 6 minus 5 is minus 11. So minus 11 x squared. Plus 2 plus 7, they give me 9. Plus 9x. Thank you, Bilal. And this is equal plus 4. So the final answer is minus 11 x squared plus 9x plus 9. And this is the final answer too. Okay, any question for this one? Makes sense, clear? So this is the addition and subtraction. Now we're going to the multiplication algebra expression. Multiplication algebra expression, we have to use the idea of the distributing property. The distributing property, we use it in the first class in this semester. So now here the multiplication of multiplying algebra expression, algebraic expression here. Here expressions. So multiplying algebraic expression. So we have to use the property, the distributing property. So I'm going to explain that by the example below. So the example is multiplying the two polynomial 2x plus 1. Okay, 2x plus 1 times the other polynomial is 3x minus 5. So for distributing, first things, when you see two polynomials and between the two polynomials are distributing, you have to use the distributing property we learned from the first class. So we have distribute the 2x with the first inside the second parentheses, and we have to distribute also with distributing the 1 with the second parentheses like this. So we're going to get right now, this is equal 2x times 3x plus 2x times minus 5 plus the one with times 3x, 1 times 3x plus 1 times minus 5. Now we can simplify. So when we have two monomial multiplying to each other, so we have to multiply the two variables and the two variables and the two numbers. So we have 2 times 3, they give me 6, and x times x, they give me x squared. Why? Because they have the same base, x and x, and different exponent, x squared. Plus 2 times the numbers we multiply by the numbers, 2 times minus 5, they give me minus 10. So here again get minus 10. And the variable, leave it alone, x. Here plus 1 times 3x, they give me 3x. And here 1 times 5, they give me minus 5. Now we can simplify it more. They give me 6x squared minus 10x plus 3. We can just adding the numbers and we're leaving the variables. So minus 10 plus 3, they give me minus 7x minus 5. And this is the final answer. Any question for this one? Is it clear for all students? How we doing, how we multiply algebraic expression? Okay, I'm going to give you an example, the last example for today, and I will leave it exercise for next time. So the example is multiplying the two polynomial 2x plus 3 times x squared minus 5x plus 4. How we can do this one? Can you give me the steps to give you the hint how we can do this one?
First we multiply 2x by x to the power 2, then negative 5, and then 4. So we multiply the first term by all the terms in the second parenthesis.
Okay, nice. Okay, perfect. Nice. Then what do I have to do? So this is the first step.
You do the same for the 3 as well.
3 the same. So I'm going to write the multiplication and I will left the simplifying for you. So I get 2x times x squared plus 2x times minus x times minus 5x plus the 2x times the 4. Okay, and the same things for the second part is 3 times x squared plus the 3 times minus 5x plus the 3 times number 4. And we can simplify each term together and we can combine all the terms together. Okay, I'm going to left the answer for you, just exercise. Any other question for today? Any question for today? Okay, we're going to stop up to here today. And I will see you next week because we don't have a class this Wednesday. Have a great day.
Do we have any homework?
Bye.